So at this point, you guys know pretty much what you need to know as far as coding in PHP to start doing some server-side apps. So what we're going to do is kind of quickly review database design and SQL commands, and we'll actually go into MySQL and create a little database and create some tables and run some code just to refresh all of your memories of what we did in 178, because it's basically the same commands here, okay? And then there's a little assignment, like a little database refresher assignment for you. And I will probably end up having a lab on Monday so that you have additional time to work on it. Okay. And so what that means is that next Wednesday, we will be creating a little application that will interface with a database. And normally, the assignment is more involved, but I am simplifying the assignment so that we can try to get all of it done in one day. Exactly. So that is kind of my plan. And some of you guys said that you had MySQL questions on the midterm, which was not my intention. So yes, I was not trying to be a mean and nasty teacher. So what I will do is throw those out. So basically, if you had that question, whether you missed it or not, you're going to get the points. So for those of you who are feeling extremely unlucky because you got a bunch of them, now you are extremely lucky because you are going to get all of those points correct. Okay? Because I think that's fair. We haven't really talked about it yet. Okay? And Cam, now you know ahead of time, don't stress on the MySQL questions. 2021? Oh yeah. I took all the due dates off of everything just because Moodle is not very user-friendly with dates. In fact, most content management systems, when you copy the course into a new semester, you can do like a mass date change and it changes all the dates for you. Moodle does not do that. You have to go into every single assignment. Yeah, so I just took the dates off. Because honestly, it's just click, click, click. It's not just one click to get into an assignment. You know, like you're clicking like 5 or 6 times. I mean, it's absolutely insane. Yeah. Well, you just don't have due dates on the assignments is what I do. So yeah, I mean, you guys all know where I put the due dates. It's at the top of the block. So yeah. Anyway. So we are going to talk a little bit about database design. This is in the book. So it's kind of like a little review, probably 30-minute review of everything that you learned about database design in 178. Yeah, so a couple of terms just to refresh your memory. A column is the same thing as a field, which is just a piece of information that you're storing. A row is basically related columns or related fields, also called a record. A table is basically a collection of related records or rows. And a database is related pieces of data. Okay, so it would be all of the different tables that are in some way related. Okay. A relational database basically lets you connect your tables together so they can share information. So on paper, tables to me look like a spreadsheet almost, right? So you've got columns and you've got rows, and at the top of each column, this would be the field name or the column name, and each row is a record, so it's got related information. So this first row is for the HGT Inc. customer. Then we've got Klein Leasing, Superior Ironworks. Okay, so it's all of their data in that particular row. Yep, and then there's an order table, and you'll notice that the customer number is in here. That would be the customer that placed the order. And the only information that you would typically duplicate among your tables is that one piece of information that you're going to use to connect the tables. So in order to see what customer placed the order, you have to put something from the customer table into the order table. And usually what you do is you take what's called a primary key, which is a unique identifier for each row. You would take the customer's key and you would stick it in the order table. And that allows you to make that connection between the tables. And that's pretty much how this one was set up, because customer number is the primary key in the customer table. Okay, and it was added to the order table so we could see what customer placed the order. And that's typically how you connect your tables. So when you take a primary key from one table and you put it in another in order to share information, it becomes a foreign key. Okay, is this all starting to ring bells? Okay, good. I know it's been a while for you too, so it should be coming more clear. What was fuzzy should be clear. Yes, yes, they do. So one of the things that we do when we're designing our database tables is we go through this process called normalization. And it's basically to eliminate duplication and to help our data stay accurate, okay? And to make it easier for us to maintain our database. And in the real world, people go through the first 3 normal forms, and that's pretty much as far as they go. And there's like 6 normal forms or 6.5 normal forms. Yeah, there's like a 3.5 normal form. But so if you normalize too much, you're splitting your tables into tiny little pieces, and that becomes really difficult to maintain. Okay, so most businesses will go through third normal form, and that's good. And so we're going to talk about the first 3 normal forms just to refresh your memory on what they are. Let's see. So first normal form. So these are all the little rules for first normal form. Basically, you have to have a key. And so the key is the unique identifier, and that ensures that you're not going to have 2 rows that are the same. And then the other key thing out of all these rules is that, yes, there's 2 things you have to remember. One is that the key makes the row unique. And then the second thing is that each column can only have 1 value. So if you have a column that could have multiple values, it is not in first normal form. Yeah. So you have to break that down. Okay. So that's the 2 most important things to remember. You know, I mean, some of these other ones are obvious. All values for a given column have to have the same data type. Well, that's pretty obvious, right? Each field or column name has to be unique. It's not going to let you create columns that have the same names. Okay? So, I mean, some of these are pretty obvious. It doesn't matter what order you put your columns. Okay? The order of the rows doesn't matter. Okay? So the 2 things that you need to remember are you have to have the primary key that makes the row unique, and you cannot have multiple values in a column. And so I kind of walk through a couple examples And let's see. So there is an example in the book, but we'll make ours a little bit more complicated. So if we want student information, which you guys are all familiar with being students. So we have student ID, student name, address, city, state, zip, major, classes, classrooms, professors, building, campus grade, GPA, credits, contact hours. All stuff you guys are familiar with. Okay. So if that was going to be our table, we would meet the requirement for, let's see. I don't even know that we would meet the requirement for a single value only, because a student could take multiple courses. So we would at least have to have two tables. We'd have to have a student table and a course table. And in our student table, probably the ID would be unique. So that would be our key. We'd have the name, address, city, state, zip, major, GPA. And then we'd have a course table with maybe a course number, a name, classrooms, professors, all that other information. So if we look at our student table and we check A through G, and usually, honestly, for first normal form, I usually just say, I look and see, okay, it has a primary key, so that's good. Is there any columns that would have multiple values? And no, it doesn't. So if I look at courses and look for the same thing, well, course number could be a key, okay? So we could make that key, so that would be unique. But then if we look about multiple values, so usually course numbers have more than one section, which means that they would have multiple classrooms, multiple professors, multiple buildings. So yeah, we have a problem in our course table. Okay, so it doesn't conform. That usually indicates that you have to break it into multiple pieces. Okay. So what if we did something like this? Oh, and plus we have multiple semesters. Okay. So what if we did semester and course number together? Okay. And then we have name, credits, contact hours, professor, classroom, and building. Would that be unique? It could be, but we'll probably break this down further. So we have a course table, we have a student table, and at this point we have no way to connect the student and the courses. And we have a little issue regarding grade. I believe we took grade out. Okay. So what if we did something like this? We did a course detail with a student ID, the semester, and the course, and their grade. Okay, and if we did all of these as a key, that would allow a student to retake a course and get a better grade. Bless you. So that would work, right? So a student could retake a course as many times as they wanted, or the college allowed, to increase, yeah, to increase their grade. Okay, so that would definitely work. Second normal form basically assumes everything's in first normal form. And this one is looking at composite keys. So if your table only has one key, it's automatically in second normal form. Okay? If it's got more than one key, then you look at each column and you make sure that both of the keys apply to that column. Okay? So the semester and the course number, does that affect the name? Yes. Does that affect the credits? And we're talking about both. Yes. Contact hours? Yes. Professor? Yes. Classroom? Yes. Building? Yes. Campus? Yes. So all of these apply to both. Okay. What would happen if they didn't? Then you'd need another table. Let's see. So our third table, course detail, has a very large composite key because it's got 3 columns in that key. Well, we only have 1 column that isn't a key. So do all 3 of these impact the grade? And they do, right? It's the student, the semester, and the course. Those 3 things combined do relate directly to the grade, because it's the grade that student got in that particular course in that semester. Any questions so far? Third normal form. So this basically deals with transitive dependencies. So it assumes that it's in first and second normal form. And a transitive dependency is when a column is dependent on another column instead of the primary key. So if the value in another column changes, it's going to impact it. So, probably the best transitive dependency example is zip code. If the zip code changes, that can change the city and the state. Okay, so city and state are dependent on zip code. So these 3 things should be removed. Okay, and typically what happens is you do a zip code table. And the zip code table has city and state in it. And zip code can be the key. Although, if you were really going to think about it, like Traverse City has 2 different zip codes. So you could make city and zip code the key. I don't really think it's necessary, but you could if you wanted to. And then you would probably just keep zip code up here with the student information. Because if you kept zip code up in student, you'd still be able to access the city and the state. Okay, so here's our revised student. And then here is our course table. And here's our student course detail. So at this point, we do have our tables conforming to 3NF. And with the revised course table, because we have section number, course number, and semester as the 3 keys. Okay, those 3 combined eliminate any kind of repeating values, right? Because if there's multiple sections, now section is part of the key. Does that make sense to you guys? For now. So that brings us to types of relationships. So you guys are probably going to be dealing with one-to-many relationships, because that tends to be the type of relationship that happens when you take the primary key from one table and you add it to another table in order to connect. Okay, you have a one-to-many. You can also have one-to-one relationships. Both of those are fine. If you have a many-to-many, that is a problem. That indicates that you need a bridge table. Okay, so you need to break it down into another table. And so graphically, how this is usually displayed is you have 1 to infinity, so 1 to many. So one student can have many course detail records, right? Because they're going to have more than one course. One zip code can belong to many students. One semester and course number can be on many students' course detail records. You would hope it was on many. If there was only one student in a course and a course number, the college would not last very long. They'd be in trouble. Yep. So a many-to-many is a problem. Here, let Let me see where I've got a many to many. I think these are, oh, here it is, orders and products. Okay, so we've got an order can have many products, a product can be on many orders. So this would need to be split out. And typically what happens is you have orders in a table, you have products, and then you have an order detail. Okay, that includes the order number and it includes a product number. Okay, does that make sense? Do you feel like you need to go through another example? Yes? Okay, because this is so much fun. Okay. So, let's say we want to track music downloads. So we are going to store all of this information. Okay. So to conform to first normal form, we do need to break into multiple tables because a customer can order more than one at a time. So we have a customer number, customer table, and we'll probably have an order table. So customer number could be a key, name, address, city, state, zip, telephone, email. And then for orders, we could have like order date, music title, album, artist, category, type, and price. It is conceivable that multiple orders can be placed on the same date. I don't know how many of you go to Amazon, you throw an order through, and then you forgot something, so you throw another order through. I just did that this morning, okay? So, to throw through multiple orders in a day. So we will add order number as a key, okay? So that will just increase with every order, so it's always going to be unique. And we'll include the order date, and then we've got title, album, all that other stuff. Now, we still have a problem because in the same order, a customer can download multiple songs. So we are going to have to break our order table down. So our revised table, we still have order number, date, and we've got a quantity. And then we have a little album, artist, category, type, price. So looking at this, it is conceivable that two songs may have the same title. So we can either do a composite key, or we can just add music number as a key. Okay? So adding music number. So we add music number, and then we fill the album, that other information. To connect the music inventory to the order, all we really have to do is take the music number and put it in our order table. And so we've got the date, the quantity, the music number. Right. We are in 1NF. So 2NF, do we have any composite keys? That's what we have to look for. And we do not. So we are in 2NF. As far as the relationships go, this is kind of how we're looking so far. Okay. So we've got our customer. One customer can place multiple orders. The music inventory table can be on multiple orders. And we would also break the zip code out because that violates third normal form. Okay, so we'd have one zip code can be on multiple customers. Okay, so you can see for third normal form, we kind of threw out the zip code. And then we get this little graphical view of our little ordering system. Does that make sense? And then you guys might think, why are we going through all of that? So the first exercise in your assignment is going to be to take a form like this and break it into tables. Now, I've actually helped you with that because there's a web page you're going to download, and I have kind of given you the names for the tables. So you will have to determine where the different columns are going to go. So I am kind of helping you with that, but that's part of the reason we are going through this, okay? So basic SQL commands. Really, the only difference between SQL Server and MySQL is that the data types are a little different. I mean, there's still variable character, there's still integer, okay? So a lot of the data types are the same, but some of them are different, okay? So as far as the commands go, like how you create a table, how you set keys, how you insert data, it is the same because SQL is SQL. So to create a database, it's just create database and whatever you're going to call it. To create a table, it's create table and then whatever you're going to name it. Opening parenthesis, you've got the closing parenthesis and the semicolon. And then it's just your column names or your field names and the data types. And then there are the properties. So if it can't be null, you'd say not null. Primary key indicates that this first one is going to be our key. Auto increment is an auto number. So this one, you never would have to add data to. It automatically will go up by 1 each time. And for a lot of primary keys, that works really well. So a couple things to remember when you are defining your columns or your fields. The size should be big enough to hold the largest piece of data. Okay, so if you are looking at data, which you would be if you were designing a database, right? You'd have data that's your sample data you're looking at. You know, you look for the longest piece of data, count the characters, and I would probably add some on to the end, just to be safe, round it up. There are 3 different categories of data types: numeric, string, and date time. And so you can see a lot of these are very similar to what we did in SQL Server. We've got some different integer types. Integers are whole numbers. Then we have real numbers, which have decimal places. And so float would be the smallest real number. Double decimal is the larger, okay? And by larger, it has more precision, which means the decimal places go out further. So, you know, if you are dealing with things like money, you do want more precision, okay? So the more precision, the better, right? You don't want the money rounding. So date and time. Date is a pretty popular format, or date time, either one. You can do time all by itself. Okay. For strings, there's character, there's variable character, and honestly, variable character is typically what's used because the length can vary. So if you say the first name is variable character 50, and let's say they only use, you know, 10, that space gets freed up. Okay, it's not reserving all 50. It's only going to use what the data takes. Okay, so most people, if it's character, will use variable character. If you are storing something incredibly large, like maybe graphics, you can use blob. And I know some of you are thinking, okay, that's a really funny data type. I'm just going to use it because it's funny. But it's actually for really large pieces of data, like graphics, okay? The maximum length is 65,535. Okay. And then there's tiny text. And you'll notice if you're really into the blob, there's medium blob, medium text. Okay. And they all have different maximum lengths, long blob, long text. What do most people use for text? They use variable character. That is what most people use. Does that mean that you guys cannot use the blob? Yeah, if you guys want to use a blob, I really don't care, but just make sure you're just storing blob appropriate data, okay? So you will notice in my examples that most of them are pretty standard. Here I've got integer, variable character. I've got text on this one, float, which has got a decimal, and integer. So very normal, no blob, just very normal data types, okay? So this would create the database, and it would create a table. Okay, and then just like we did in SQL Server, insert into, basically is how you get your rows. So if we had a grocery inventory table, it's insert into grocery inventory, and then in parentheses, these are all the columns. Then we have values, and in parentheses, this is what we're going to insert. Now, one thing that people mess up, and they do it in the 178 class, and they do it in here, is that if it's an integer, if it's a number, you do not put it in double quotes, okay? The only thing you put in quotes is text. So you do have to kind of pay attention to what your data types are. So it's kind of important. So our ID was an integer, so we just put a 1. But then the name and the description, well, they're both text or strings, so we put them in single quotes. Then we've got our price. That was a float, so you'll notice I have a decimal in there, okay? And then the quantity is an integer. Okay, so you just have to match the data with your data types. So what I did in here is you'll notice that there is a lovely gold square around certain sections of code. This code we are going to copy and we are going to paste in MySQL so we can create the grocery database and we can add values into it. So you can kind of get a feel for how MySQL works. So in here, that means we're going to use the dev server. So we're going to run it as the administrator. Like at home, if you're using Laragon, all you have to do to get into MySQL, and you're really accessing phpMyAdmin, that's the interface for MySQL. All you have to do is launch Laragon, hit start all, and then hit database. It'll take you to a screen where you have to log in, and it fills in the username as root. There is no password. All you have to do is hit the button to log in. Yeah. Yeah. So in here, you're going to want to start all of the servers. So I right-clicked on the little E down here. I'm going to restart all the servers. And then I'm going to open the dashboard. And I can see that my HTTP started, but my database did not. So I have to hit start because that has to start. And so is everybody at this point? Okay. Where are you at? Did you right click and restart the servers? because if it can't start the HTTP, it will not open up the dashboard. Okay. Yeah, you might have to run it as administrator again. Here. Sometimes. I don't know, sometimes it's funny and you have to do it more than once. There you go, and that actually started. All right, so what we are going to do, where it's got modules, and you'll see MySQL administration, PHP MyAdmin, we're going to hit open. So this is the interface for MySQL. And right now we have no databases. Once we have the databases, they are going to display over here. Okay. You can also access them by hitting the Databases tab. Where you enter your SQL code is right here. Okay, so what we're going to do, we're going to highlight this because this is all SQL code you guys should be familiar with, or it should look familiar because we worked with it enough in 178. So we're going to copy. And we're going to paste right in here. And then you'll see a go button. You're going to hit go. And you're going to hope that everything comes back with lovely green check marks because that means it worked. And then over on the left, you're going to see your database. Okay. And then if we look, we've got our grocery inventory. We can see our columns. And if we go over to the database tab, okay, you can see here's the grocery database. And if we select it, then that gets us into the table section. Okay, and so you'll notice that there are some commands here you can use. One of them being drop. So you guys all remember how to delete tables, right? You have to drop them. Well, here you can actually use the command button to remove a table. So it's actually pretty easy to do. And if we click on grocery inventory, it actually opens it up. And then these are the rows that we added. And you'll notice there's an edit button because we can edit the data in the row. We could copy the data and we can delete. And the reason it's important that you guys know how to kind of get down to look at the data is because eventually, in a couple weeks, you're going to start working on your final projects. And your final projects are going to involve interfacing with a database that you create. So you're going to create a database, and then you're going to do the web interface for it. So you are going to be inserting rows. You are going to be updating rows, reading the data from rows, and deleting. So in order for you to make sure that you're doing everything right, you need to come in and look at the data. That's the only way you can tell if your code is really working. Okay. And I will, not today, but before you guys start working on your final projects, I will show you what the production server looks like, because this interface that you guys see is the exact same as what I see on the production server. And I've already set up databases for you for your final projects. Basically, I just used your username as the name of your database because in the past, when I didn't do that, people had their databases named the same, and it was kind of a nightmare. So your username, your NMC username is your database name, and you'll be adding tables to that. Okay, that way everybody stays separate. Okay, and it works way better. So we are going to go back over here. So this is what we saw, right? And we're going to go ahead and add more to our table. So here's the user tree, so that should look familiar. And we've got a couple insert intos. So we'll do a little copying. And we're going to go back into the SQL window. Just paste over what's there and hit go. And I will, if there is an error, you will know right away. Because instead of seeing this lovely green with the check mark, it displays in kind of a pinkish red color. So it is letting you know that it's not right. So now that we talked about an error, I am going to have you guys do a little copy paste here so you can see what an error looks like. Not that you will ever get errors in here on your own, but it is kind of nice to see what they look like while we're practicing. So this one, we are going to get an error. And the reason that we're going to get an error is because we're missing the ID. Yep, so it should give us an error. Yep. So this is what their errors look like. Column count doesn't match value count at row 1. So that is kind of a weird little message, right? So we're doing an insert into, it says the count doesn't match. That is what it's trying to tell us. And what we're missing is the ID. And the ID happens to be our primary key, so it's rather an important thing to put in. So if we do the and we specify the columns and we put in a 5, okay, then it should work. So if we copy paste over this, and now we've got the columns listed, and we also put in a 5, and we hit go, that really cryptic in here. It is not always the picture with all of the SQL commands in it. Okay, so these are all the SQL commands that you guys are going to need to use to create your tables. So we're going to go ahead and add a couple more. And if you guys want to sub in different foods, you can. I'm just going to keep them the same. The drop command works the same as it did in SQL Server. We are not going to drop our table since we have been going through the effort of adding rows to it. But it's basically, you know, you're going to use your database. It's just drop table and then whatever the name of the table is. You could also choose to use the interface, right? So we can select whatever our grocery database and get, up to the database level, and then it would list all your tables, and you can drop by clicking on the link here too. This would execute the drop table command. Okay, so it's pretty easy to, create and manipulate your tables. You can actually edit the structure in here as well. There's a structure command. So you can edit in here. You'll notice you can change, you can drop. You can specify primary keys, okay, all sorts of things you can do just in the interface, in addition to using your SQL commands. And MySQL is super popular on the web. It is free, and it is used all over the place. Let's see. And I already kind of showed you how to remove the database. To run a select command like this, we're going to copy, and we're just going to go into that little SQL interface. Okay, and then it shows us all of the data that we currently have in our table. Okay, and are you guys remembering how to format these commands? So the asterisk means all columns. Otherwise, you can specify which columns you want to see, from the current table or whatever table you're looking at. You guys remember the order by clause for sorting? Yes? What about the people who it's been a while? Yeah, so this is all basically one command, right? Where you tell it the database you're going to use, select, give it your columns, from, give it your table, and then order by is your sort order. So you have to give it the name of the column you want to sort by. And it's going to do it in ascending order. So if you decide you want descending, you just have to put DESC after it. After the column you're sorting by and before the semicolon. Okay, and here it's actually sorting by two different columns. So it's doing everything by item name, and within name, it's sorting by quantity. The limit clause is going to limit to top values or two values. So if you guys want to practice that one, this is not quite used as often. So we've got select everything from grocery. We're going to order or sort it by current quantity, and we're limiting to two. So basically, it's just going to show us the two at the top of the list. Or at the top of the sort order. And so there's variations that you can have with this command. Where clause acts as a filter. Okay, so it's going to limit the rows that you see. And typically if you use where, you're going to have some column, relational operator, and some value that you're checking. Okay, so if we ran this, it was only going to show us the items that have a quantity equal to 500. Okay, if we run this one, it's only going to show us the items that have a quantity less than 100. And then it's going to sort by quantity. Hey, is this all coming back to you guys? Coming back like a bad cold? I don't know. Okay. So do you remember pattern filters? So where we have select whatever columns you want from the table, where your column, like, and then you give it a little pattern. So the percents in front of and after pack mean that anything can come before pack, anything can come after pack. So the item name has to have pack somewhere in it, okay? And if it does, display it. So it's looking for this pattern. Okay, here's another one where it's looking for a pattern, and we're specifying that it has to have an S at the end. Doesn't matter what's at the beginning, the S has to be at the end. Okay, so for this one, we're looking for an item name again. CH has to be at the beginning. Okay, so does that make sense to you guys? Exactly, yep. Yep, so that's what a like does. And between, you basically give it a starting and an ending value. This is the column we're looking at, current quantity. And it's only going to show the rows that have values between the starting and ending value. And you guys are going to be using selects to read from your database tables. Okay? In fact, when you code up the select in PHP, it looks a lot like it does here. Okay, so here is another one where we're looking at price, and it's between 5 and 20. Is this making sense to you guys? Okay. Selecting from multiple tables. So hopefully you guys remember joins. And just using the join statement is going to give you an inner join. And that's the most restrictive, right? So we're smiling because we love join statements, right? No? Okay. So here we're going to be creating another table. And we're going to be populating the table. And then we will, let's see, it looks like we're running a little, this is it's implicit join. So we're going to first do this. I'm going to create a produce table. So produce, we have a code that we are saying is our primary key, season, color, and a vendor. And then we're inserting 3 rows. And then what we want is to display the code, which is coming from produce. We're going to display the item name, which comes from grocery inventory. We're going to do the season and the color, which comes from produce. And we're saying from produce and grocery inventory. We just put a comma between. So this is called an implicit join, okay, where we don't use the word join, but it is going to join the tables. Okay, and we're looking for rows where the code is equal to the ID. Okay, so we're going to go ahead and run this one. And we're not going to get a whole lot of results because we only have 3 things in our produce table. Okay, so we only got 2 results, codes 1 and 2. But you can see it pulled item name from the inventory table. So here's another one. This is an explicit join because we're actually telling it inner join. So just using join and saying inner join are the same thing, okay? And so we're going to go ahead and we're going to run this one. And you'll notice with this, we've got produce.code equal grocery inventory.id. So the where clause is pretty much the same. It's just that we have to use on now because we're doing an explicit join. Okay, so we got the same results, which is what I expected, because the implicit and the explicit join were both doing the same thing, right? It was looking for the ID equal to the code. It's just two different ways of doing it. So a left join. If you remember, a left join pulls in everything from the left table. It only shows the matching rows that are on the right. So you might have some empty or null values if there's not matching data for the right table. And let's see. So we're going to create a little database called people. And we're going to create a table called names. And it's very simple. It's got an ID, a first name, and a last name. And we have very famous cartoon people in this. So copy this. And we'll paste it. So now you'll notice that we have another database over here. Okay, and we've got ID, first name, last name. And we're going to create another table. So this table is going to be called email. And all we've got is an ID and an email address. Bless you. So let's say we want to do a left join. We want to display first name, last name, and email address. And we're going to join names and email. We're using a left join, so it should show everything from names and matching email addresses. And we're doing this on the IDs. Okay. So what we're going to end up seeing is we're only going to see emails that exist. And then we've got several people that don't have email addresses. Yeah. Well, you know, they were in the prehistoric time, so can't expect them to have emails. Okay, so it went ahead and executed, and you can see that we do have several that came back null. So if we do a right join, let's say we do the exact same thing with a right join, what's going to happen is it's going to show us all the emails and then anything that matches over on the name side. And you'll notice we do have one email in our email table that does not have a person. It was Spacely Sprockets. You have to pick on the bad guy. Is this all coming back to you guys now? Yeah. So updating, basically you use the set command. So we've got use grocery, that's our database, update grocery.produce, so produce is our table, set code equal to 8. Probably the most important thing in a delete or an update is the where statement. Because if you forget where, it changes everything, okay? Yeah, so if you forget everything else, do not forget to use where. So where the produce code equals 10, okay? So we're gonna go ahead and run that because it should change our produce code. And it did, 1 row is affected. Yes, if it came back and it said, 10 rows affected, then you would be concerned. Or 1,000 rows affected, yeah, that would not be a good thing. Here's another example where this is grocery inventory. For ID number 6, we are setting the current quantity to 10. Let's see, another syntax you can use is replace into. This would be more if multiple columns were changing. Set works really well if one is changing, but if multiple are changing, replace into makes more sense. And this is just like insert into because you're giving it all of your columns. You use values and then you're telling it what the new values are. So deleting, again, most important thing that you're going to remember about deleting is the where clause, because the where clause tells it what to delete. Otherwise, it's going to delete everything. Alter table. If you need to change your table structure, you will use alter table. Okay, so if we ran this, we're saying use our grocery database, alter the grocery inventory table, add receive date. It is going to be variable character 10, and we're telling it to add it after item description. And then we're doing a bunch of updates for each of the IDs, and we're setting the date. Okay, I'm not going to make you guys run this. I'm just trying to refresh your memories. Okay. If you need to remove a column or a field. Okay, so if you're removing something and it deals with a database or a structure, you always use drop. Okay, so alter table grocery inventory drop receive date. If you need to rename, this is how you would do a rename command. It is conceivable, if you guys are playing with PHP MyAdmin and MySQL, you could end up with a lot of databases and you could end up with a lot of tables. So the show commands do come in handy. So if you go in here, go into SQL, and you do show databases, and you run it, okay, it actually should tell you what your databases are. And some of these are administrative, like we created grocery and people, the other ones are administrative. And just like you can do show databases, we can also execute a show tables. But we have to say use database first. Okay, so we could say use grocery, show create table produce. That would actually show us some of the code. And if you guys remember privileges, we talked about this at the end of the 178 class. So privileges are basically granting users access to a database, to a table, to a particular schema. Okay, and so you can do that here as well. In fact, I will show you how I had to do that on the production server. It's actually a little different on the production server. I don't create the databases or the users or grant permission in MySQL. I have to use a different interface. So I'll show you guys what that looks like on a production server. Okay, just so you guys get a feel for it. String functions. So all of those functions that we covered in SQL Server exist here. So you can concatenate your strings. So if you want to display something with the first name and the last name and a space, you can do that. The padding and the trimming functions exist here. In fact, all of the SQL functions exist here. So there's nothing that you guys could really do in MySQL that you cannot do here. Does that make sense? All right. So I will let you guys review this because I don't think we need to talk about every single function that exists because we had a whole class that dealt with that. Subqueries, everybody's favorite topic. Subqueries exist here too with the same rules as SQL Server. So you can use it with a select, an insert, an update, a delete, a set. Remember, a subquery is an entire query inside another one. So to help you guys out, I did do a little command summary, okay, of different commands that you can use. So hopefully if you guys forget syntax, you can just kind of come in here, take a look. Yes, it is rather lengthy. Chapter 17 gets into transaction processing. We don't really get that far into this in MySQL. But if you remember, commit means that it was successful. And so as long as we run commands and we see the green, it's successful. Okay, it's committed. But the minute something is unsuccessful, it rolls back. It backs out of the change. Okay. If you wanted to create procedures, you can. You just have to use the create procedure command. You can create your own functions just like you could in SQL Server. Everything is pretty much the same. Okay, and if you wanted to know more about transaction processing, I do have links to that. Okay, is it necessary for you to review transaction processing for this course? No, it is not necessary that you review that for this course. What we're focusing on is for you guys to create a database with multiple tables for your final project, and then you're going to be using code to do the CRUD functions. Okay, that's kind of what our focus is. And you're going to have to set it up on the test machine and make sure it all works. And then you can either send me the code to create your tables, or I will log into the server and you can create your tables on the production machine. And then you will switch your connection string to the production machine. In the test environment in production, there is not a problem.